Hello, everybody. We're going to continue our lesson on section 17C, optimization, and we're going to talk about some optimization problems. So often we get problem-solving, word problem kind of questions with optimization, and here's an algorithm that we can follow to help us. And just notice, this one's not from your textbook, but there is a similar one on page 429 of your textbook. So for optimization problems, your first job is going to be to assign variables to the given quantities and the quantities to be determined. And if you can, draw a sketch. You're going to write an equation that needs to be optimized, which means we need the thing that we need to max or min in terms of the two variables. You need to find values that are sensible or feasible for the problem situation where the derivative of the equation to be optimized equals 0. Basically, that means determine the domain and then do our calculus backup plan. Take the derivative, set it equal to 0, and solve for x. Finally, you can verify that you have a minimum or maximum using the first or second derivative test. And remember that if you're given a domain, a specific domain, you need to test the endpoints as well. So here's an example. And it's a little hard to read. We might have to continue it in the next video. I'll do my best. So the product of two positive numbers is 48. Find the two numbers so that the sum of the first number plus 3 times the second number is a minimum. So first job is to define the variables, something I like to call notation. So we're going to let x be the first number and let y be the second number. Then I'm going to create a model, okay, or the equation that I need to max or min. In this case, I know that if I multiply those numbers together, I get 48. But the problem is I can't minimize or maximize this because it has two variables. So I need to kind of, I need to fix, this is one of the things we're told. This is the other equation that we're told. We're told that the sum of the first number plus 3 times the second number is a minimum. This is the one we want to minimize, but again, it's in two variables. So we have to use this extra information to help us isolate for one variable. And so we're going to solve for y in the first equation. Y is going to be 48 over x. I'm going to substitute that into my second equation here for y. So I simplify and get x equals, s at x is x plus 144 over x. And I might rewrite this so it makes it easier to take the derivative. Now, when I think about the domain, the lowest possible number is approximately 0. Okay, it could be a decimal, but it's not going to be less than 0. And the highest possible x is whatever 48 divided by y is. That's not a very useful domain right now. It's just might help us if there's real endpoints. My next job is to find the stationary points, and for that I'm going to do my calculus backup plan. So I'm going to take the derivative of this function, which is here. I'm going to set it equal to 0, and I'm going to solve for x. And when I isolate for x, I find that x could be plus or minus 12. Then I'm going to draw my sign diagram. And remember, I'm going to include these critical numbers, except remember that they told us that x and y are positive numbers, so negative 12 isn't a possible solution. So we're only going to consider 12. So we know our number has to be somewhere between 0 and infinity, but 12 is a critical number. I'm going to plug in possible values and determine if my derivative is positive or negative. So if I substituted in, say, 10 into my expression here, my derivative, I would get a negative value, which would indicate that my function is decreasing. And if I plug in a number larger than 12 into my derivative, I would find that my derivative is positive, which indicates that my function is increasing. That means that since I'm going from decreasing to increasing, I must have a minimum at x equals 12. Oh no, don't move, don't move. Okay, so now the last thing I'm going to do is test I'm going to find my extrema. Those are my extreme points, maxes or mins. So I'm going to evaluate s at 12 and find out that that's 24. And I'm also going to test my endpoints. I can't test infinity, but I can test 0. So I'm going to evaluate s at 0. It doesn't exist, which means I must have the absolute minimum at x equals 12. And in conclusion, I just need to answer the question. They asked me to find the value of x and the value of y. So x is 12, y is 48 over 12, which is 4. So the two numbers are 12 and 4. Thank you.